of you who I didn't have maybe when you walked in. If you're still not quite there, so and how to figure these things out, the impedance of an inductor, there's the ratio of V to I, the voltage across an inductor, pull that in. Assume the current takes on this form if I have sinusoidal sources, and then calculate the derivative, cancel, and I get Li omega. Okay, so that was question number 1. Question number 2. If I have some sinusoidal source such that omega equals 2, let's calculate the impedance of the following circuits. And let's say this is 2 ohms, 3 henries, and 0.1 farads. Before I do it, I want you to tell me what the units of that 2 are. So just saying omega equals 2. What units should that 2 have? And maybe to help you with that, this omega is part of some sinusoidal function, like 3 sine omega t equals V1 or some voltage, okay?
1 over seconds?
Which is radians.
Roger, is that a hand up to answer?
It was radians or 1 over seconds, which is the same thing, right?
Well, actually, it's both combined. After I'm done, omega t should have units of radians. Plus you. Because the sine of some angle, the angle would be a radian. So omega times t is radians. The t has units of seconds. So I need something times seconds gives me radians. And then Roger, what would that be?
I don't know.
Oh, you almost said it. That's why
Radians per second?
radians per second,
Oh.
which is almost what you said, Roger.
Oh, okay.
So, because radians per second times seconds gives me radians. So the argument of the sine function, what goes in there, has to have units of radians, so I can figure out that the omega would have units of radians per second. So that omega would be radians per second. That omega is sometimes called the angular frequency. Last class we reviewed, not learned, reviewed how to connect omega with the frequency that you might see on, say, the wave tech. When somebody talks about frequency, they're not talking about radians per second. When they use frequency, they mean cycles per second. So if I jump up and down like this, that was what do you think about? Twice per second? My frequency is 2 hertz. How many things, how many repetitions per second? So there my frequency is 2 hertz. Omega does not have units of hertz. It's not 2 cycles per second, it's 2 radians per second. So on Tuesday we connected omega with frequency, and we found that there was a factor of 2 pi difference. Another way you could look at that connection is if you have 2 radians per second and you want to convert to cycles per second, you could use the factor label method. So radians per second, I need to go from radians to cycles. So my conversion factor has to be radians and cycles. So the radians cancel and I'm left with cycles. How many radians are in one cycle? So for the sine function, how many radians are in one complete cycle? 2 pi. So 2 pi radians equals 1 cycle. So 2 radians per second would be 2 divided by 2 pi cycles per second. And that's my frequency. That right there is F. I don't need to know F for this problem, but in the laboratory, the equipment is set up to produce different frequencies. So the wave tech is not producing omega. You dial in on that knob. You're dialing in the frequency F, not omega. So if you're asked to set up a certain omega, you'd have to do this conversion. Okay, so I've got some omega, 2 radians per second. I'd like to know the impedance of this circuit between A and B. So this is maybe what I'd almost call like a plug and chug question. We don't have to think too hard about it. To figure out the impedance from A to B, we have to figure out the impedance of the capacitor and the inductor. Then I can use all the same rules I had for resistors earlier on. Looks like I'd be combining these three in series. So let's first figure out the impedance of that capacitor. The impedance of that capacitor is 1 divided by I omega c, which is 1 over I times 2 times 0.1, which is 5 divided by I. 1 divided by 0.2 is 5. Still have the I in the denominator. Does that I represent current or the square root of -1?
The square root of -1.
The square root of -1, good. I can multiply top and bottom by I, and I get 5I divided by I squared. What's I squared?
-1.
-1, which is -5I. Okay, so the impedance of the capacitor is -5I. What are the units on that? Ohms, good. -5I. What is the impedance of a 3 Henry capacitor if the omega is 2?
6I.
6I, good.
Would it be 6I or negative 6I? It'd be 6.
Positive 6. It's Li omega.
Oh, that's right.
Not negative Li omega, not divided by I. So what is the impedance of this whole thing?
So 2 plus
2 plus I? Yep.
Yes.
They're all in series, so I add that plus that plus that. So the impedance is 2 plus I in a unit, 2 ohms. Done. So we're looking for the, if all we're asked for is the impedance, then we leave our answer with an I in it, if necessary. All right, question number 3. Actually, I'm going to, well, no, I won't skip it. Question number 3, I was going to make sure you understood how to graph things. So this is a algebra 2 question, but it's just, sometimes it's good to review something. Suppose I have V1 equals 3 sine 2t, and V2 is equal to 2 sine 2t plus 60 degrees. So got 2 voltages in the circuit. Can I graph both of them on the same graph? So can I make a sketch? Am I going to prevent you from using your graphing calculator to do it? No. Do I recommend that your only method for being able to make sense of that is to use your graphing calculator? Definitely not. So we'd like to see if we can figure out what these graphs look like. See if we can develop some intuition with these functions. So let me graph V1 with the white chalk, and then I'll put a different color on for the other one. So I just want to see if I can graph these 2 functions. The amplitude of this function is a 3, so it means the biggest it can get is 3, and the lowest it can get is -3. It's a sine function. It has no phase shift, so it's going to look like that. What remains is to figure out the period. So I need to label the period on this graph. If it were just sine t, what would the period be? 2 pi. If it's sine 2t, is it going to be twice the period or half the period?
Half the period.
Half. It's going faster if there's a 2t there. So that period is going to be pi.
So it was basically 2 pi divided by whatever number that is?
Yes, excellent.
Oh,
Excellent.
yesterday I was multiplying it. That's right.
Okay. But good observation. 2 pi. If you think of it, if you like a formula, James just gave us a formula. James just said, suppose that's an omega. The period is 2 pi divided by omega. There's a formula. If you see someone running around with a formula sheet from physics, if they've covered waves and things, you'll sometimes see people with that formula out there. So formulas are good if I have to do something 10 times in a row, or if I have to enter it into Excel. But we want to understand where that formula comes from. So James made my day by coming up with the formula rather than reading off of the sheet. I had a couple students asking to kind of review sines and cosines since they're showing up a lot this last week. From talking to those students, I think what a lot of you are missing has nothing to do with sines and cosines, if you're missing anything. Some of what you're missing is the idea of shifting or stretching functions, period. So if you come to me with a question about what that 2 does, I'll tell you what my answer is going to be in advance. Some of you have already experienced this non-answer answer. I'm going to immediately switch from sines and cosines to parabolas. Or I'll go to some exponentials. I'll go to some other function and say, what happens if I replace t with 2t? It's always better if you can learn something that applies to a million situations instead of something that applies to one situation. Definitely learn the version that applies to a million situations. So if you're a little fuzzy here, I think it's because you're unsure how to shift any function and unsure how to stretch or compress any function. All right, so there's my sine 2t. How about the 2 sine 2t plus 60? So we'll put that on the graph. That plus 60, am I shifting to the right or to the left?
To the left.
To the left, yes, we looked at that on Tuesday. I'm shifting 60 degrees. 60 degrees is what fraction of a full cycle?
Third.
1/6.
1/6. 360 degrees is a full cycle.
I
It would
thought
technically
you
be
meant
one-
of that cycle.
It would be,
1/3 of that,
Yeah.
right?
Because that's only.
well, 60 degrees is, if I put a 360 there, that would be shifted a full cycle. I think what's getting you confused is you're saying the period's only pi, so maybe it's only 1/3 and not 1/6. It's still, look at that number as a fraction of 360 always.
Oh, okay.
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 So it's shifted 1/6 of a full cycle.
Of its full cycle.
Yeah, 1/6 of its full cycle.
Because if that 2t was another number, it would be
The
a different
cycle would be
scale.
different.
Yeah.
Yes, it's shifted 1/6 of its full cycle to the left. So it's shifted pi over 6 to the left, and that's a quarter of a full cycle, right? So it's shifted 1/6 of a full cycle, so is it shifted more or less than that? Less. So the peak is going to be like here. The reason I went down is because the max is 2, not 3. So there's 2. Something like that. So I've drawn 2 different voltages that might exist in the circuit. The original in white. The second has been reduced in magnitude and shifted in phase, and I've tried to capture close to that. Okay, Fred.
So if there was no 2 there, it'd just T, it'd be the
Here?
cycle.
Or here, or both.
Both. The cycle would be 2 pi.
Right, in fact, if that were changed, the only thing I'd have to change on my graph would be that. And everything else would look the same.
But would it, if it still has the same frequency, its frequency would be, the whole thing would be shifted. Like its location for pi would be different as well, right?
Well, I changed the pi to a 2 pi.
No, I'm ignoring Fred's question. I'm going back to
Okay.
the original.
Okay, back to the original. No offense, Greg.
They both have the same omega,
They both have the same omega of 2t, or 2.
so their cycle is in pi, is completed within pi. but it's shifted over 60, so wouldn't the completion of that one's cycle be also over a sixth from pi?
I tried to draw it a sixth over there, and a sixth over there, and a sixth over down here, and a sixth over there, and a sixth over there.
Okay,
I may not have drawn it perfectly, but I tried at each key point to shift it a sixth to the left.
okay,
A sixth of this full cycle, which was pi.
okay.
Would it also
And
work?
all I knew about, what I did to draw the sixth is I knew that that was a quarter, so I did a little bit less than that. That's the best I did with the diagram.
Okay, thank you.
If you made 6 tick marks and then just drew it based off 1 tick mark over to the left, would it work?
Yeah.
But, yeah,
So how do you go from degrees to radians again?
180 over pi.
360 over 2 pi.
Yeah.
You're just keeping the ratio the same.
Several correct answers. I like to think of it as